Hello everyone and welcome to a new video. In this video we will be introducing a new term which is called the resistance. Let's start off with a simple question. We know that electrons can pass through conductors easily compared to insulators. But do all conductors allow electrons to move at the same rate? Well, I think the answer is clear. It is no. So not all conductors allow electrons to move at the same rate. And every material has a different opposition to the movement of these electrons. Some of them allow electrons to move easily, some of them they don't. Although they are conductors, they are both conductors, but some of them allow electrons to move easily. This opposition to the movement is called the resistance. So the resistance is the opposition of the movement of electrons inside a conductor. And the higher the resistance, this means that it is harder for the electrons to move. So high resistance means that the electrons are not able to move easily. Low resistance, the electrons can move easily. The unit of resistance is measured by something called ohm. And we will be talking about Ohm's law in a few minutes. Now, copper is known to have low resistance. That's why it's mostly used in wires. But does that mean that all types of copper wires have the same resistance despite its size or length? I think we all know the answer to this. It is also no. There are three factors which affect the resistance of a conductor. These factors are as follows. The length of the wire. So let's imagine that we have a short wire and we have a long wire. Where do you think we will have more resistance? Actually, it's in the long wire. Long wires have more resistance than short wires. Well, this means that the electrons will have to move a longer distance, which is harder. And we said when it's hard for the electrons to move, that means we have high resistance. So long wires have higher resistance than short wires. The cross-sectional area of the wire itself. Let's imagine that we have a thin wire and we have a thick wire which has a larger area. I think it is clear that for the thin wire it will have a higher resistance, while in a thick wire it will have lower resistance, because in thin wires they give less space for electrons to move. Imagine if it was a stream of water, it would be easier for the stream of water to move through a thick pipe than to move through a thin pipe. So we can imagine resistance in this case as a flow of water. And finally, temperature. The higher the temperature, the higher the resistance. That's why it is recommended to keep electrical appliances such as computers away from heat, because high temperatures will increase the resistance. Okay? Actually, the resistance in circuits is not only inside the wires. We can find resistance in other locations. Actually, we can add certain parts to the circuits to increase the resistance in the circuit. These parts are called resistors. We can control the resistance inside the circuit by adding resistors. The resistors turn the potential energy inside the electrons passing through them into other forms of energy, mostly heat. But other examples, such as a lamp is considered a resistor. Why? Because it transforms the electrons that carry energy that passes through them into light, which is a form of energy. So not all resistors transform energy into heat. Some of them transform them into light. Some of them transform them into sound, and etc. And as we said, other types of resistors change energy into heat. An example is the electric heater. The electric heater turns energy, which comes from electricity, into heat. So it's a shape of resistor. The relationship between resistance, what we studied in this lesson, and the current and the potential difference, which we learned about in previous lessons, is governed by Ohm's law. What does Ohm's law say? It says here that the resistance in a circuit is equal to the potential difference divided by the current. And we know that the unit of resistance is ohm. And here you can see the shape of the ohm. It's also called omega. So omega here, in this case, it means ohm. Ohm is the unit that measures resistance. And we know the current measured by amperes. And finally, the potential difference, which is measured in volts. We learned earlier that current is measured using an ammeter. So we can use the readings from an ammeter and something called a voltmeter to find the resistance. There is no device to measure the resistance. So if we want the resistance, we will need to find the current and find the potential difference inside this circuit. Then we can use Ohm's law to find the resistance. But what is a voltmeter? A voltmeter is simply a device that measures the potential difference. And we will be studying it more in details in the next videos. There are many types of resistors. As we mentioned, a lamp is a type of resistor. Another very famous type of resistor is called the variable resistor. It is a resistance that can be modified to a certain value. So we can increase the resistance inside a variable resistor, or we can reduce the resistance inside a variable resistor. As an example, the computer radio. It's actually a variable resistor. Sometimes if we want to lower the voice, we would increase the resistance so the amount of energy reaching the speakers will be less. Or if we want to make the voice higher, we will reduce the resistance, making more energy reach to the speakers, and therefore we will hear a louder voice. So one of the main or one of the most used types of resistors is called the variable resistor. Here are some symbols used in circuits. This is a voltmeter. It's simply a V inside a circuit, and it measures the potential difference. This is an ammeter. We've seen it before. The ammeter measures the current. And this is a symbol used for the variable resistor, which is a resistor that can change its value. And finally, we use this shape if we want to talk about a simple resistor, which gives resistance to the circuit. Stay tuned in the next video where we will be solving some problems on Ohm's law.